Hello and welcome to another video in the pre-calculus series. This one is on determining the equation of perpendicular lines. So two lines are called perpendicular if the angle formed between them measures 90 degrees. This is denoted as L1, the line for L1, an upside down T symbol, and then L2, and that upside down T symbol means perpendicular. So this would be L1 is perpendicular to L2. Another term associated with perpendicular is orthogonal. The procedure to determine perpendicular lines is as follows. The first step is to determine the slope of one of the lines used to determine if the lines are perpendicular, and call it M1. To find the slope of the line perpendicular, consider -1 divided by M1 if M1 does not equal 0. If M1 does equal 0, the line must be horizontal, and thus a vertical line would be perpendicular to it. The third step is to find the y-intercept of the line with the slope -1 over M1. And the fourth step is to determine the form of the line desired, whether it be slope-intercept or standard form. So here's an example to find the equation of a line perpendicular. Let's assume that 3 points are provided. And our example is stated as follows. Find the equation of the line perpendicular to the line formed by the ordered pairs 1, 1 and -5, 4 that contains the point 2, 2. So we have 1, 1 and -5, 4. Those 2 points are going to be used to form one line, and then the line perpendicular to that has to contain the point 2, 2. So the first step is to determine the slope of the line we are to be perpendicular to. We call this M1. We plug it into the slope formula and do the arithmetic, and we get -1/2 as the result. Next, we consider the opposite reciprocal of this value. So the perpendicular slope has to be -1 divided by M1. In this case, -1 divided by -1/2. And when I flip that over, I get, and change its sign, I get +2. So I found the slope of the perpendicular line. Third, we find the y-intercept using the point slope formula. And again, this is the y-coordinate minus m times the x-coordinate. But these coordinates have to come from the point that the perpendicular line has to go through. And this, for our example, this is the point 2, 2. So we have 2 minus 2 times 2, which is -2. And finally, we write the result in slope-intercept form, y equals 2x minus 2. So our line perpendicular will be 2x minus 2. Things to note. Determining the y-intercept for the first line is not required since the slopes are different. The lines are already distinct. Notice the steps of finding the equation of a line are still applied here. We still follow those steps. Find the slope, find the y-intercept, and finally write out the equation of the line. Here's another example. Find the equation of the line perpendicular to the line y equals 7 going through the point 1, 5. Well, if we proceed with our usual steps, step 1 is to find the slope of the perpendicular line. Now in our equation for the line that's already provided, y equals 7, the slope is equal to 0. So if I try to take the opposite reciprocal of 0, I get something undefined. Now, this doesn't mean I quit. It just means that a vertical line is what I'm going to want. So our second step is to find the y-intercept, but vertical lines don't have a y-intercept unless they are the vertical line x equals 0, but this one is not. But we do know that this particular vertical line has to go through the point 1, 5. And whenever you're going to say a vertical line goes through a point, we just need the x-coordinate of that point, and that'll be enough to provide us with the line. So our third step is to write the equation of the line. X equal 1 will be the line we seek because it will be perpendicular to the line y equals 7, and it does go through the point 1, 5. Here's another example. Find the equation of the line perpendicular to y equal to 4x minus 2 through the point -1, -3. So again, we proceed as follows by following our steps. Find the slope of the perpendicular line. So we pull out the slope of the line that we're given, which is 4, and we take the opposite reciprocal of 4, and we get negative 1/4. Then we find the y-intercept, and again, that means we plug in the point that we need our perpendicular line to go through using our perpendicular slope, and that means that we have the y1 minus perpendicular slope times x1. Y1 will be -3, x1 will be -1. So we plug those numbers in, and we get -3 minus negative 1/4 times -1. So we end up with -3 minus 1/4, and we know that's -13/4. Our third step is to find the equation of the line in slope-intercept form. We found the slope, we found the y-intercept, so we just put it into that form, and we end up with y equal to -1/4 x minus 13/4. Thank you for your time and attention.